안녕하세요. I hope I said it right. I think that's where my Korean stops. So I'm a big fan of Korean dramas and K-pop. I watch a lot. It's like my everyday thing after work. So I picked up few Korean words. I'm still working on it. So thank you so much for staying until this last session. So today I'm just going to take you through end-to-end MLOps in Snowflake. Before we start, I'm just going to say a little bit of intro about myself. I'm Sheena. I'm working with Snowflake as an AI ML FCTU for APJ region. So I've been working in the data science space for more than 12 years now. I've been working in different countries like India, then I was working as a researcher in Japan, then I moved back to Singapore, and finally I'm here with the Snowflake. All right, so our agenda for today is very simple. So I'm gonna take you through an introduction of Snowflake ML. Basically, it tells you how to do your AI ML in Snowflake, and ML development and ML modeling API with Snowflake, how to build the end-to-end ML in Snowflake, and finally we'll finish it off with some resources, some summary, if you guys want to get started, where you want to get started and stuff. All right. Snowflake ML. So this slide basically summarizes all the features we have for ML in Snowflake. So starting from the top, which is Studio. So the Studio is for the people who just want to use no-code and low-code interfaces to build the AI ML models. And it is generally available, so you should see all these features right now if you're using Snowflake, and you can get started. And we also have a Snowflake notebook, which helps you write all your code. You can choose your environment, packages, and things like that. And going to the next layer, which is the middle layer, we have ML functions, which is, again, if you are a very SQL savvy person and you want to develop AI ML models, then this is for you. It's very easy to build AI ML models using SQL functions in Snowflake. And next comes to the custom ML dev and ops in Snowflake, which we uses for our feature engineering. You can use a feature store and a model registry. So the main topic for this session is going to be this custom ML DevOps and MLOps Python APIs in Snowflake. And on top of this, we can run in any of this infrastructure for compute that's provided by Snowflake. If you're a user of Snowflake, you can understand you have been running all your queries into what we call as the warehouse runtime. So the warehouse runtime is the normal compute that you use to run queries in Snowflake, but now we have introduced a new runtime, which is known as container runtime. So why do you use container runtime? It is 40% cheaper than the warehouse runtime, and also you can leverage the flexibility to bring in any packages that you want, or also if you want to leverage some GPUs. So this is the best way. You can just go in and use our container services. Right. Going to the ML development, Snowpark. How many of you have heard about Snowpark? Anyone? No, okay. Okay, I saw one hand. Okay, that made me happy. Starting with Snowpark. So anything that you want to write in Snowflake, which is not SQL, you need Snowpark. As simple as that. It has no relationship with Spark, even though the name is very confusing. Nothing to do with Spark. But if you want to write SQL, not SQL, which is Java, Python, Scala, we use something known as Snowpark API in Snowflake. And how does this API help? It basically is very simple. It helps you to push your code towards the data. So you can start writing your code in your Visual Studio notebook or in your Jupyter notebooks or any IDE that you have been using. But if you run the code in Snowpark ML, it's gonna take that code and push it near the Snowflake data, and it is getting executed inside Snowflake. So basically, there is no data movement, and your extra cost of taking data out of Snowflake is also not there. and it's much faster. We'll take a look into more like how it is well optimized and faster than the normal other Python packages as well. And again, on top of it, you can choose your warehouses, CPU, GPU, container services, whichever you want. When it comes to ML modeling, there are certain operations that are very computationally expensive. It takes a long time to run. So how can you run these operations faster is to distribute them. To manually distribute these operations is very cumbersome. It's very difficult. But Snowpark ML does this for our customers behind the scenes. So for you, it's very simple as writing a line, but behind the scenes, we will be distributing the operations like pre-processing, one-hot encoding, which is computationally expensive, and also the model training part as well. What all can we do with Snowpark ML modeling? So you can bring in your data, pre-process it, and do your feature engineering, followed by your model training, whichever model you want. If you want to use TensorFlow, PyTorch, or scikit-learn, anything that you want to use, you're free to use and build it in Snowflake. And then we have model optimization with hyperparameter tuning. This will distribute your hyperparameter tuning. What happens is like it becomes much faster. Again, you can train multiple models with data partitions, followed by automating the workflows. We have a task API, and finally, you can do all your MLOps, your model registry and feature store with RBAC controls on who is accessing what, etc. So now let's take a look at why do you use Snowpark ML? So this is one of the main questions my customers always ask me. Oh, I want to use scikit-learn. We have been always using this. Why should I use Snowpark ML? So this is basically my answer to that question. Because of the distributed processing and the fastness in which you can process your code. So on the first bar graph, right, unfortunately I don't have a pointer, so it's on the first one. What we are trying to do is we are trying to run a standard scalar operation, which is again a computationally expensive operation on a 200 million data set, which has 200 million rows, and it is run inside Snowflake with both Snowpark ML as well as scikit-learn. So remember this, we are running it inside Snowflake, so there is no data transfer time or anything. The time is similar for both these experiments. And here you can see, if I'm running it with scikit-learn, the transform and the fit operation, that the time that it takes is much, much higher than when I use Snowpark ML, which is the second bar graph from the left side. So similarly, for even one hot encoding operation, it's always very, very small because we are distributing it out of the scenes. So we are talking about a 25 to 50x faster than you run scikit-learn. So that's the catch here. And data is not moving out of Snowflake, everything remains there. We push the code near the data and we execute it in a distributed fashion faster. Again, going to one more operation, which is very computationally expensive if you're coming from an AI ML background, which is correlation. So for correlation, we are using 1 million rows with a 512 column data set. And what you can see is that it takes around like 650 seconds for processing without Snowpark ML. But the same operation, the same code, the same data, with Snowpark ML, you can see it only takes like 51 seconds. So that's a huge difference. Model training. So when it comes to model training, Snowpark ML API has out-of-the-box support for scikit-learn, XGBoost, LightGBM. It's built as a wrapper on top of all these packages, basically. And if you want more flexibility, if you still want to continue with any of the Python packages, like sometimes you need TensorFlow, sometimes you need PyTorch, or sometimes you even want to continue with scikit-learn, you're free to do it in Snowflake as well. This is an additional extra package that we provide for our customers, especially when they're dealing with a huge amount of data. All right. And then distributed hyperparameter optimization. If you want to try a lot of hyperparameters and trying to train it with Snowflake is much simpler because we distribute the hyperparameter tuning out of the box for you. The code you can see on the side, it's pretty simple and similar to what you write it in scikit-learn. It's just one line of code for your grid search, but we will automatically distribute it. And there on the bar graph, you can see, if you want like much faster execution, you can increase the warehouse size from medium to X large, and you can see the time for execution is significantly going down when choosing an extra large. Now, this is a very new feature that we have in Snowflake, so I'm really excited for this feature personally. So I met with one of our customer who asked me like, hey, I have 60 million customers, and I want to build one single model for every customer. So we are talking about 60 million models for one use case. They want to know what my customer is gonna spend in the next 1 year. So this question came in and we're like, okay, we have to build 60 million models, one model for each customer for just this one use case. So this was our solution, which worked wonderfully. You don't have to partition data out of the box or do anything. You can just simply write the code and specify what is the partition column. If you can see on the bottom, the second line, you specify the partition column, which can be a store. For example, I have a store in Seoul and I have a store in Busan. Now I want to build separate models for each of my store, or it can be each of my product. I have 10 products that I'm selling. So retail companies, how I want to sell it, or how I want to build a demand forecasting model for my 200,000 products or million products. So each of this model need a separate ML model. So this is how you can easily build with Snowflake. And the scalability that we can afford is like amazing in Snowflake. And we have Snowflake notebooks, which is very easy, out of the box. You can just come in, start coding right away. You don't really have to go outside of the Snowflake ecosystem to write your code. We have a model registry where most of our customers are using this one, where we have 400 plus models created daily and 4,000 plus daily inference job that's happening. So it absolutely take care of the distributed inferencing behind the scenes for you. So you just give the data, let's say 1 million rows, and call the model, that's it. Out of the box, Snowflake will cut it into batches and take all this and do it in a very distributed fashion for you. Feature Store. Feature Store is also one of our new feature that we have, and this really helps you in multiple ways. So if you want to create a feature store, and then you can distribute this feature store to the other teams. So it helps in collaboration. So I'm from the product team, and I'll create the feature store because I'm only the one who is aware about which columns are important for the product. So I'll create this, and then I'll pass it to the marketing team. I'll say like, hey, marketing team, I want you guys to collaborate. So this is the latest values and the clean data that you have. You can leverage it and do something. Similarly, you can pass it to multiple teams. So that enables a lot of collaboration. So some of our customers, this is how they enable the data democratization across like everyone, opening up your data to every single team so they can come in and have those amazing ideas and take the data, clean data out of the feature store and build those use cases. And then another major use for feature store is that if it is an incremental data, so you have a base table where every single day one transaction row is coming. Your customer makes a transaction and the transaction data is coming in your base table. So every time you want to build an ML model or run inferencing on this data, this is called incremental data because the data keeps on coming every single day. So in that case, usually you have to build a lot of pipeline out of the box to make sure it is working right, you're not messing up with the data, you're not missing the data. But in this case, you don't have to. If you create a feature store, it will automatically get those incremental data. By the time a new row lands in the base table, it will be automatically doing all the processing and getting and adding that row inside your feature store table. So that takes the head out of it. Okay, so end-to-end ML, how does it look in Snowflake? So this diagram actually explains the end-to-end ML in Snowflake, where your data is in data lake or inside Snowflake. And from there, we can do the preparation and transform the data using Snowpark ML modeling. And that's how you basically build your training set. And when you build your training set, this is usually the practice we have been, most of the companies have been doing, but the best practice is to use a feature store in between. You can see in the bottom, after your preparation, you have to push your data to the feature store. Once you have the data in the feature store, you have to retrieve the training data set always from the feature store, which should be the standard practice in AI ML use case. Once you have the training data set, then we are going to use our Snowpark ML modeling API again to build this model. Once you finalize your model, okay, I'm happy with the model, the performance is great, and next step is I'm gonna push it to the model registry. So this one is basically a handshake point between two teams. Not everybody should have the permission to push a model to the registry, because that's very risky. Not everybody should play around with the model that is existing. So that's why we have this model registry where you can put RBAC controls, who can read the model, who can run the model, and all those things can be imposed on a very fine-grained level inside the Snowflake model registry. And you can also store the artifacts, the metadata, everything together with it. Finally, it goes to the inferencing stage. So we call the model out of the registry for inferencing, and then you also get your inference data from the feature store and pass it to the model that is retrieved, and finally you get the predictions. So again, the model retrieves the data from the feature store. This is exact same case I mentioned before, that a new data about a transaction is coming in. So how do I get it inside the feature store, which is my new row that came in, and I want to see whether this is a fraud transaction or not. So if you set up this pipeline, it will automatically take care of all this incremental data. That is new row of transaction data coming in. It automatically gets it, run with the model, and detects it whether it is a fraud or not. So we built all this pipeline. Now what? The best thing about Snowflake is like, how can we automate this one? So we provide a task and a DAG API to automate this entire pipeline for AI ML use case, so that you can completely automate it. You can put your monitoring alerts. For example, the pipeline fails, I want to get an email on it, or I want to get a Slack message on it. So that's also possible. So with this task and DAG API, it's pretty simple. It's like if you have used other tools like Airflow, it's similar to that. You can define how task 1 is followed by task 2 and how all this execution takes place. And the best part, we also got a UI for it. So you can see on the top, that is how we chain the task or chain the pipeline, where you are executing task 1 followed by task 2, then you want to execute parallel task. In the end, on the right side, you can see how we execute 2 tasks in parallels. So all these things can be found in the UI, and also it will give you a clear description of all these details, how much time each of these tasks in the pipeline took to run, and what was the total duration, what was the scheduled time in which the task was run, and also the return value if you want to check anything. For example, my task 1 returned no, then I want to check. If my task 1 returned no, then I don't want to run task 2. So all these conditions, you can just take the return value and make a condition on top of that. And also it shows you the whole status of the task. If one of these tasks is failed or skipped, basically you will get an email alert. You can configure the email notification or Teams notification or Slack notification. So it will tell you like, hey, we failed in this task. All right, summarizing it. So our customer word speaks larger than whatever I say or a marketing says. So this is from one of our customer called Patronics. So they have achieved a 70% cost reduction by using Snowpark ML, and also moving from running hour-long inference job to prediction in near real time. We can run like micro batches, mini batches, all these inferences that can really accelerate the inferencing time and run your models faster. What from here? This is where you start. Please feel free to take a picture of it. So this QR code will help you get started with Snowpark ML. We have a lot of quick starts, which is a detailed information of how to build end-to-end AI use case in Snowflake. So you can just go there, the code is readily available. You can just download it, run it in Snowflake, and learn how to do an end-to-end ML inside Snowflake. So the quick start link is the one on the right you can see, and on the left you also have the documentation which explains how this entire thing is done. That's all from my side for today. Thank you for being here. Thank you.